crazy. All right, let me get the e-session going. All right, first thing we're gonna do is we're gonna review from last week. The first thing that we did last week is we talked about taking derivatives of trig functions and natural log and e to the x. So what I'd like you guys to do is I'd like you to find the derivative of both of these problems here. See if we're material from last week, because it's going to come in real handy this week when we're doing the product rule and the quotient rule. All right, so let's see here. Problem number one. If we were going to do this problem, let's see here. Oh, my marker's not working here. Let's change that. Change that color here. 1 second. Okay, so the first one is just e to the x, and last week we learned that the derivative of e to the x is e to the x. It is the only function that has itself as its derivative. So, and the number in front just stays. So this is just going to be 2 e to the x minus, and then the derivative of cosine of x is positive, or is negative sine of x. So that's going to change this to a positive 5 sine of x, and then the plus 5, or the plus 3 is the constant. It's going to just become 0. So 2 e to the x plus 5 sine of x is absolutely correct. Second one is natural log of x. This is 1 over x. So it's just 12 over x, which is absolutely correct. Now that's going to come in real handy this week when we start doing the quotient rule and the product rule. All right. A couple more examples from last week. See what you guys get there. All right, negative 3 sine of x plus 8x is correct. So now we're using trig functions and the power rule. So in this problem, the cosine or the derivative of cosine of x is just negative sine of x. So this becomes negative 3 sine of x plus 8x. And then the second one, the derivative of sine of x is cosine of x, so that's negative 4 cosine of x plus 9. Ooh, you guys are good. Very nice. Excellent. All right. So this week, ooh, I forgot this problem. Every week I've been trying to throw in an equation of a tangent line or an equation of a normal line, because I think they're so important. I mean, that's basically what we're trying to do, is we're trying to find a derivative so we can find the slope. So what I'd like you guys to do is I'd like you to take a look at this problem. It says, given f of x equals 4 cosine of x, find the equation of the tangent line at x equals pi over 2. Now, you should not be using a calculator to find the values of pi over 2 or any of those trig values, okay? Last week we did talk about finding those values and how you would do it. So tell me what your equation would be for this. All right, let's take a look at the answer, Isabel, that you gave, because I mean it might be. The problem is I don't like the way that you write it. Okay, and the reason, and I'll go through the reason. I mean, obviously, if it's right, it's right. But in this problem, the first thing I do is I look at it and I say, okay, what two pieces of information do I need? And that always, when you're writing the equation of a tangent line, you need a point and you need slope. Okay, so my point, I already know my, oh. Sorry about that. Some bug just flew into my eye here. So the point, we have pi over 2, that's my x value. And then I need to know what my y value is. Well, okay, so I have to plug it in here. So pi over 2. Again, I just, real quick for, so I just, real quickly, I just draw out my graph here. So this is going to be 0, pi over 2, pi, 3 pi over 2. So pi over 2 is 0. So if I put 0 in here, 4 times 0 is going to be 0. So that's my point. And then my slope, well, I got to take the derivative here. So that's going to be -4 sine of x. If I put pi over 2 in there, again, I just draw out my graph real quick. And it seems like pi over 2, it looks like it's 1 there. So that's -4 times 1, which is -4. So now I have a point and I have a slope. So if I want to write my equation, I see what you did on that one. Y is equal to 0, or y minus 0 is equal to -4, x minus pi over 2. Okay, you just got rid of the 0 there. Now, a lot of students, if you had something like y minus 2 is equal to -4, x minus pi over 2, would you rewrite this in slope-intercept form, or would you just leave it in point-slope form? Okay, all right. So I still have some kids that are still rewriting point-slope form into slope-intercept form, and it's like, no, don't do that. But this one, I guess it was pretty easy. Just get rid of that 0 there, and you just have y's. Okay, all right. Any questions on the review from last week? Some really good problems on there. All right, so let's go to the no, we just did that problem. Okay, so here is this week's what we're going to do this week, and we're going to be dealing with the product rule and the quotient rule. Now, somebody emailed me about I think it was you. Where did it say to E? I thought it was practice number 7. I'll have to go in there and look at that, because last week you were supposed to go into not Khan Academy, the AP website, and do the practice 7. I didn't know it was. Somebody said it was this week, which is kind of weird. Because I made it for last. I did the week 8. All right, so I must. The practice link doesn't work. Nothing in AP Classroom either. Oh, how about last week? Were you able to do the practice for week 7? Okay. See, this week I think you were just supposed to go back to Khan Academy. Yeah. No. I only do that once in a while. I'll throw something in there from the AP Classroom. But I didn't. I was looking at the thing, and I don't see where it's. Oh, it does say once you completed all the lesson, please go to. Oh, I need to get rid of that. Bummer. Yes, you are absolutely correct. So is it quiz 3 on Khan Academy that matches up with this week? Oh no, got the spinning wheel. Okay, now I had the spinning wheel on there, so I didn't I don't know if you guys heard me or not, but Khan Academy, I'm not. Let me go into my grade book and see what quiz it's supposed to be this week. I apologize. I thought, yeah, it just quiz 3 on quiz 3 differentiation and basic derivative rules. So it should be the Khan Academy quiz 3, I believe. Do it. I'm going to change that in here. Okay. All right. So whatever you do is fine. It just, yeah, it doesn't really make a difference. I know you guys know your stuff. Okay. This week we're going to be talking about the product rule and the quotient rule. Here is the product rule. The product of two differential functions, u and v, is differentiable, and the derivative of uv is equal to u dv dx plus v du dx. The derivative of the product is actually the sum of the two products. Yeah, now in English. Okay. Let me give you an example of what we're talking about here. If I gave you a function like, let's say, y is equal to the sine of x times e to the x. Okay, there's no way. What a lot of kids would do is they just take the derivative of the sine of x and derivative of the e to the x, and they'd say the derivative of this is cosine of x e to the x, which it is not. Okay, when you have two functions that are multiplied together, you have to use what is called the product rule in order to get the derivative. Okay, now I'm going to show you how I teach the product rule, and you can use it or you don't have to use it. I would, if you use it, it will make the quotient rule that much easier. I always tell students to let one of the functions be u. Okay, so I'll just put u. So over here, I'll just write u is equal to the sine of x. And then I'll put u prime is equal to, and then you just take the derivative. Well, the derivative of the sine of x is cosine of x. Okay, and then the other function is v. So I put v over here. So v is e to the x, and then you take the derivative of that. So that's e to the x. Now, if you do it this way, u prime, v prime, then your answer is you multiply the two inners together. Okay, so my answer is going to be cosine of x times e to the x, e to the x, plus, and then you add the outer terms together. So that would be sine of x, e to the x. And that is the derivative for that function. It's kind of a crazy one, isn't it? I mean, it's like, whoa. Usually our derivatives, when we take a derivative, it gets smaller. But when you have a function times a function, it actually makes the derivative a little bit bigger than your original function was. Okay, so I always teach students to go u prime, v prime. No, it's the same thing here, u dv dx. I mean, if you take a look here, this would be dv dx plus v, which is v here, and u prime. So it is the same thing as this up here. But once you realize that this is the whole case, and when we do the quotient rule, we follow basically the same rules. Okay? Any questions so far? I'm gonna give you a problem to do yourselves. Okay? So I'm just gonna make one up. I mean, that's the beauty of these. I mean, you can take the derivative of anything as long as you give me two functions. So let's say I gave you natural log of x, because we worked with that last week, times, let's say, cosine of x. Okay, so that's two functions, right? I have a function here. And it doesn't matter which one you say is u and which one's v. That makes no difference at all. So what is the derivative of the natural log of x? So if this is my function, y is equal to, then what is y prime equal to? What is the derivative of that function? Cosine of x over x plus natural log of x times the sine of x. Okay? Do we agree? No, I haven't done the problem yet. So natural log of x, sine of x, plus cosine of x over x. It looks like you guys have the same thing. It doesn't look the same, right? But it sure is the same. I mean, it doesn't matter which direction you write those. It is the same. So if I was going to do this problem, first thing I would do is over here, I would go u. The first thing I always do, v, before I even look at what functions I'm going to put in there. So I've got natural log of x here. So that's going to be 1 over x. Then I've got cosine of x. And then that is negative sine of x. Inside plus outside. And I say that to myself over and over again. So cosine of x over x plus, and it doesn't really matter which way you put this, negative sine of x, natural log of x, makes no difference at all. So it sure looks like you both got it correct. Now I'm going to really test your knowledge. Yeah. I'm going to ask you to write an equation of a tangent line to this function at x equals 0 without using a calculator. Ooh, Mr. Shanklin, without a calculator. Okay, what two pieces of information do you need in order to write an equation of a tangent line? That's the first thing you should be asking yourself. Point and slope, okay? So point and slope. Well, my point is 0, comma, what? What's that point? If you plug 0 into that function, what do you get? Well, most people don't know what natural log of 0 is. What's another way of writing natural log? Isn't it log base e of 0? Oh, that's not going to work. Ha! That's not going to work. I should have put 1 here. Let's go. Let's change this and make this a 1. Oh, but that's going to be, no, that's going to be too hard because cosine of 1 is going to be a decimal. Okay, forget that. I thought it was going to work out nicely, but not going to happen. Sorry about that. All right. So this is the product rule. Let's try some examples. Okay. Uh-oh. Sine of x, e to the x. Tangent of x. Let's I think we did this one already. Or one very close to that. So let's not deal with that one. Let's deal with this one. Okay. So work on that, see what you get for there. First of all, what is the derivative of tangent of x? Does anybody remember that? What is the derivative of tangent of x? Secant squared of x. Awesome. Okay. All right. So find the derivative, or find that. Handy post-it note. Awesome. It's exactly what you should have, because when you're doing these types of problems, you just look at it, and the more you do, it's like pretty soon you won't even have to look at that. You'll know. Oh, tangent. That's secant. That's just secant squared. 2x tangent of x plus secant squared of x, x squared plus 5. Secant squared of x, x squared plus 5. Now, Isabel, I'm gonna say that I would mark yours wrong, and the only reason I would, okay, and I'll explain this, and you know, some kids understand what I'm saying and some don't, and it's ticky-tacky, there's no question about it, but it is right or wrong. Let me show you why I would mark yours wrong. Okay, so in this problem we have u, let's go tangent of x, u prime is equal to secant squared of x, v is equal to x squared plus 5, v prime is equal to 2x. Okay, inside plus outside. So if I did inside, I could rewrite it as secant squared of x, and then you put x squared plus 5. But in reality, if that's what you did, this is what you're really saying, is you're saying secant squared of x times x squared plus 5. When in reality, you're saying, I believe you're saying, secant squared of x times x squared plus 5. So there is a difference if you don't put parentheses in there. You're missing that. And a lot of kids, they miss that, and it's like, oh man, I hate marking it wrong, but it is incorrect. Okay, so you just got to make sure you put those parentheses in there. Plus, and then this would be tangent of x times 2x. And this one you don't need parentheses because you don't have a plus 5 or something on the back end of it, so it'll be fine. But that is a ticky-tack thing to mark wrong, but it really is incorrect. Okay, so just make sure that you put your parentheses in there if you need them. All right, couple more. Now, some kids, when I first started teaching calculus, a lot of kids, I would give kids this type of problem before I gave them the product rule, and they would just multiply through here. They'd say, oh, I can use the power rule on this problem. I could just multiply through here, and I'd end up with x to the third plus x to the third times x to the 1/2. If the bases are the same, we could just add our exponents together. So I'd end up with x to the third plus, what is that, x, what is that, 6/2, so 7/2, x to the 7/2. And then you could use the power rule on this. And you'd end up with 3x squared plus 7/2 x to the 5/2. Now, if you use the product rule, I would assume your answer is not going to be the same. Now, it is going to be the same. It's just it won't look the same. Okay, so let's do this. Let's see if it works out. If I did this, u is equal to x to the third, u prime is equal to 3x squared, v is equal to 1 plus, and then I'm going to go x to the 1/2, and then v prime is equal to 1/2 x to the negative 1/2. So really it's going to end up being 1/2 squared of x. Okay, so inside, so I've got 3x squared times 1 plus the square root of x, plus outside, well, I've got x to the third times 1/2, so that's going to be, now, you look at these two answers, and you'd have to say to yourself, those don't even look close. But I guarantee you, if you did the math on this, if you simplified this thing down, it will be exactly the same as this problem. And where, you know, you get to the point where it's like, oh man, how much math do I want to do in order to simplify a problem down? Normally, you don't have to simplify anything. This is perfectly fine for the AP test. They don't ask you to, you know, rewrite the thing in simplest form. They don't. You can just leave it as is. So I would not even worry about it. But if you wanted to check yourself, you could actually work this problem through, and you would get the same answer. I mean, you have to. I mean, we're doing of a function, the rule correct. So, but I wouldn't deal with that. This problem, I wouldn't multiply through either. I would just, you know, a lot of students, they'd say, oh, I just do the power, or I would just multiply through and use the power rule. No, that's probably not the way I'd do it. I would just go u is equal to 2t to the -1 plus t to the 5th. U prime is equal to -2t to the -2nd plus 5t to the 4th. V is equal to t to the 3rd plus 1. V prime is equal to 3t squared. And as soon as you start realizing how quick this is, it's not, the product rule is not that bad. And then I'm just going to rewrite this as -2. I'm going to put the t squared on the bottom because I don't like negative exponents. And then times t to the 3rd plus 1. I'm not going to multiply this out. There's no way. Plus, and then 3t squared times 2 over t plus t to the 5th. And you do not have to write this out. Now, I'll take that back. Sometimes you'll find that you'll have a multiple choice test and they'll have it simplified from here. So sometimes, but I rarely have seen that. Okay, so you really don't have to do that. Okay, I do have a question for you guys off the topic of product rule. Are you guys thinking of taking the AP test? And I mean, it's either yes or no. I mean, you know, some kids don't. Okay, did you get the sign up sheet to sign up for the AP test? They said that they sent it out. Okay, they said that they sent it out like in September. Okay, I'm gonna resend that out. So you go, because I think you have to sign up by November 8th or 6th, one of the two, in order to be signed up. It's in the eAchieve newsletter, I think. Okay. Well, I was told that it was sent out specifically to all the parents and students, and I didn't get it. So I don't know if they just didn't send it to me. You didn't get it via email? Okay. All right. Then the person that told me they did send that out was not being truthful. Okay. So I will get a hold of that and I will send it out so people that want to take the test can see it. Okay. All right. Now we know the product rule. Let's talk about the quotient rule. If you think the product rule was crazy, take a look at the formula for the quotient rule. V du dx minus u dv dx over v squared. What does that even mean? All right. So if you followed along with my u prime, v prime, I'll show you what this means. The easiest way for me to do it is just to show you an example. So let's say I gave you y is equal to e to the x over sine of x. Okay, so this is where we'd use a quotient rule because we have a function over a function. I'm going to call the top u, so I'm going to do exactly what I did before. U is equal to e to the x. U prime is equal to e to the x. V is equal to sine of x. V prime is equal to cosine of x. Now this time it does matter what u and v are. Okay, the top one has to be u, the bottom one has to be v. You can't mix those up because it messes up the product. Now remember we said inside plus outside. Guess what? When we're doing the quotient rule, it's inside. So I've got e to the x sine of x minus the outside. Okay, so that's e to the x cosine of x all divided by this squared. The original v squared, sine squared of x. That's my derivative. So product rule is inside plus outside. The quotient rule, inside minus outside divided by bottom squared. Okay, and I used to say that over and over and over again until it just sunk in. And it's like, okay, quotient or product rule, inside plus outside. quotient rule. Inside minus outside divided by bottom squared. All right, let's give it a shot. This one's yours. X to the third minus 4 over x squared plus 3. What do you get for the derivative there? And don't multiply things out. I'll see a lot of kids, because right away we know the bottom has to be x squared plus 3 quantity squared, right? Because that's the bottom squared. That goes down here. I know that, and I know something's going to go up here with a minus sign in there. Okay, I know that. Don't multiply this out. You don't have to. Just leave it as is. Okay, I see a lot of kids doing all this multiplying and doing FOIL and all that, and it's like, not needed. Just leave it as bottom squared. So I did the hard part. I did the bottom squared. What goes on top? 3x squared times x squared plus 3 minus 2x, x to the third minus 4, all divided by x squared plus 3 to the second power. Not bad, is it? I mean, when you start learning these rules, it's not bad. I mean, you just have to follow along. So now if I was going to do this problem, I've got u is equal to x to the third minus 4. U prime is equal to 3x squared. V is equal to x squared plus 3. V prime is equal to 2x. Okay, so I've got middle. So I've got 3x squared times x squared plus 3 minus outside. So that's going to be 2x, x to the third minus 4. And that is exactly what you had. Awesome. And that is where I would keep it. I would not multiply everything through. Now, obviously, I can multiply this stuff through here and subtract and all that kind of good stuff, but you don't have to. You just leave it as is. Now, as I said, you might find a multiple choice question where it is simplified down from here. I wouldn't do it unless you had to, because I would never ever make you multiply those things out. I would just leave it just like that. Okay, any questions on the quotient rule? So we'll have a couple more examples here. Okay, so let's try another one. Yeah, we'll try both of them. All right, I'm gonna turn off my mic. I'm gonna let you guys work for a little bit, see what you get for both those problems. Ooh, that bottom one. Yikes. Can anybody tell me what? There is a problem with that bottom one. Okay. Can you see where it's going to cause some problems? I mean, it's a pretty good problem. Exactly. You have to use the product rule on the bottom. Yeah, definitely. No question about it. So it really is the quotient rule, but the product rule is inside of it, because there is no way you're going to take the derivative of this without the product rule. Well, I suppose you could multiply it out if you wanted to, but you do have to use the product rule too. Awesome problem. I'm going to turn off my mic and let you guys Okay, I am going to start working through the first one because it's going to take a little bit of time to do the second one. So the first problem, I'm going to go u prime, v prime. So u is equal to z squared plus 1. U prime is 2z. V is equal to z to the third minus 5. Z or v prime is a 3z squared. Inside 2z, z to the third minus 5, minus outside. So that's going to be 3z squared times z squared plus 1 all over bottom squared. So that's z to the third minus 5 quantity squared. Done. Boom. Okay. Now that one was fairly easy to do. It wasn't too bad. Now the next one that is going to be a little bit tougher. So again, I'm going to use u squared, or I'm sorry, u prime, v prime. Oh, you got the answer? Woo-hoo. Yikes. All right, so u is equal to t squared, u prime is equal to 2t. V is equal to t minus 4, 2 minus t to the third. Well, then I have to take the derivative of that. Well, the derivative of that is the product rule. So down here, I'm going to do u prime, v prime. So u is t minus 4. The derivative of that is just 1, isn't it? Is equal to, or v is 2 minus t to the third. So v prime is negative 3t squared. Okay, so inside, so I've got, so that's going to be my derivative here. So it's going to be 2 minus t to the third times, I'm sorry, plus the outside. So that's going to be 3t squared times t minus 4. Whew, that's a heck of a heck of a derivative there. All right, so now I've got negative 3t squared, not positive. Negative, oh, is that negative 3t? Yes, it is. I've got inside, so that's going to be 2t, t minus 4, 2 minus t to the third, minus outside. Hey, that's a lot of outside there. So that's going to be t squared and then times this whole thing. So that's 2 minus t to the third. I'm going to have to put a couple parentheses in there, aren't I? Minus, oh, so that's going to be a, oh, that's a plus. Yeah, but then a negative 3t squared times t to the minus 4. That's going to be a minus, a parenthesis, whew, all over bottom squared. So that's going to be t minus 4. Again, I'm going to use a couple sets of parentheses here. 2 minus t to the third, all squared. Whew, I wouldn't even want to find, you know, because what do we use derivatives for? We use them to find the slope at any given point. Oh, could you imagine finding the slope using that derivative? I mean, I suppose if you gave me like 0 for my t value, it wouldn't be too bad. But oh man, it's a pretty, that is a pretty tough one. So that's, I mean, when you think about derivatives, most of the times your derivatives get smaller, but when you're using the product and quotient rules, those derivatives can get mighty long. All right, these two should be much easier. Now, these two you have to decide. Are you going to use a product rule or are you going to use a quotient rule? And that's where some kids really struggle. They don't understand when they're supposed to use each of the rules. When do I use the power rule? When do I use, you know, the trig rules and all that kind of stuff? So take a couple minutes, see if you can figure out these two problems. They shouldn't be as bad. It looks like you both got the same answer for the first problem. Awesome. All right, you guys can keep working on the second problem. I'm going to work through both of them. So in the first problem, I'm definitely using the product rule because I have two functions that are multiplied together. So I'm going to go u is equal to negative 7x to the third. U prime is equal to negative 21x squared. V is equal to e to the x. V prime is equal to e to the x. Inside, so I've got negative 21x squared times e to the x plus outside negative 7x to the third. And that's exactly what you guys came up with. Nice job. Now the second one, same thing. I'm just going to use the quotient rule now. So u, I'm going to say is sine of x. U prime is equal to x. V is equal to e to the x plus 5. V prime is equal to e to the x. Inside, okay, so I'm going to go cosine of x times e to the x plus 5 minus outside. So I've got sine of x e to the x all over bottom squared. So that's e to the x plus 5 quantity squared. All right, I'm just checking your answers. E cosine of x e to the x plus 5 minus sine of x e to l. Very nice. Ah, looks like you both have the same answer there. Sine of x minus. Yep, very nice. So that is the product rule and the quotient rule. Two rules that, you just have to follow along. Now, if you don't like the way that I do the problems, like inside, outside, I've been teaching calc for a long time, and I always find that it's easier if you can, say, like inside plus outside or inside minus outside over bottom squared. And if you say it over and over and over again, pretty soon it's just ingrained and it's super easy to take the derivatives. But you can go back to the formulas. I mean, that it does work also. Yeah, those formulas, when I first looked at those formulas, definitely not those. So I just had to find a way that worked for myself, and you guys might find a different way that works for yourselves. It's, math is an interesting thing. As long as you're doing the right steps, you're okay. All right. I believe this is our last problem today. It says find an equation of a tangent line to the graph of f of x equals x over x minus 1 at 2, 2. So this time they gave us the point, right? 2, 2 is our point. So the only thing we really need to do is find the slope. So I already have, as soon as I see equation of a tangent line, the first thing I'm doing is I'm writing down point and slope. Well, they gave us the point. All I need is a slope, and then I can write out my equation. I can, really, if you're taking a test and you're running out of time, right away you should just write down y minus 2 is equal to something, x minus 2, right? I've got 3/4 of the equation done. The only thing I don't know right now is this little piece of information right here. I don't know the slope, and that's where we have to find or take a derivative. Okay, so you guys tell me what the slope is. The slope is -1/2. Okay, do we agree with that? I'm not so sure. I haven't done the problem yet, so I would probably say it probably is correct because you guys are smart. So let me, if I was going to do this problem, I've got u prime, v prime. So u is equal to x, so that's 1. V is x minus 1. V prime is 1. Inside, x minus 1 minus outside, that's just x, all over bottom squared. So if I wanted to find 2, I just plug 2 in here. So 2 minus 1 minus 2 over 2 minus 1 squared. So 1 minus 2 is 1. Uh-oh. -1. I end up with -1, unless I did something totally wrong. So do you agree with -1? I mean, as I said, I'm just doing this one really quick. You cancel out the x's in the numerator. I think you could do that. I mean, when you think about it, you've got x minus 1 minus, you could go like this. So those x's do cross off. So you're left with -1 on top. So you could have crossed out the x's on top. You'd still end up with -1 up there. And then x, you foiled x minus 1 squared. I just plugged the 2 in there. 2 minus 1 is 1. 1 squared is 1. I'm going to go with -1 as my slope there. So I'm thinking this is my correct answer, or the correct answer for that problem. You foiled wrong? All right. Mr. Shanklin's right. That doesn't happen too often, let me tell you. All right. That is it for this week. The quotient rule and the product rule. Next week, we deal with the chain rule. Now, the chain rule, once you learn the chain rule, oh my goodness. The chain rule, you can do the chain rule inside we're gonna have a problem like this next week. It'll be like sine to the third of 3x squared plus 4. This is like the chain rule. It's like a chain rule inside a chain rule inside of a chain rule. This is when it gets pretty interesting. So be prepared next week. And it's only one rule next week. It's the chain rule, but it'll make it so we can do a lot of different types of problems with sine and cosine. Right now, we can only do sine and cosine of just x. Next week, we'll be doing, if you have the chain rule, you can do the sine of 3x. Because what the chain rule says is you take the derivative of this, so that would just be cosine of 3x, but then the chain rule says you also have to take the derivative of the inside. So the derivative of 3x is 3. So the derivative of sine of 3x is really 3 cosine of 3x. So the chain rule, it's not a hard rule, but when you start doing problems like this, when you have the chain rule inside the chain rule inside the chain rule, it gets a little complicated. All right. Any questions on anything that we did this week? How do I access the practice for this week? The link on the pace chart doesn't work, and I know you said it is 3, but how do I? It'll just be just the Khan Academy quiz 3. Yeah, there's nothing in the AP site, so you just take the quiz 3 in Khan Academy. Yes, in Khan Academy. Yep. You just take the next quiz, the one with the product rule or quotient rule. Yep. You don't have to do anything in the AP site this week. How do you find that? Did I not put a link? I probably didn't put a link there. I'll put a link in as soon as I get done. You don't even have to take the practice. Just email me and say. I mean, I know you guys know your stuff. So just email me and I will open up the assessments for you. But I will go in and do the quiz 3 for everybody else. All right, you guys have a great week, and I hope to see you back next week for the chain rule. It's awesome. Bye.